Hello guys, good day, welcome back to my channel. And for today's tutorial, I will be showing to you how to prepare the initial sizing or report. So this is just a report from the ETABS software. Tapos gagamitin natin yung PDF editor. So I'm using today BlueBeam. So as you can see, we have here the 3D model. This is from the ETABS. As you can see, this is the extruded view of the model of your structure. So, kailangan kasi ng initial sizing. As you can see, ito na-analyze ang design na to. So, considering the maximum forces for every element. For example, for the columns, depending on the size. So, kinukuha ko yung maximum, then I consider it to the design and the sizing of each element. And I have a design tools. Ito yan eh. Extract X Pro yung gamit ko dito sa pag-design. Although you can design directly in the ETABS, but you can check it manually. Kasi may nag-failure, although pasado siya sa, kung i-consider mo yung forces, failure siya, failure sa design ng ETABS, pero kapag i-manual mo, pasado siya kasi, I don't know, I think there's some consideration based on the code. So, kaya nag-failure siya. So, much better if you will consider the actual forces and you will consider it in the designing using the other software. So, I have here the initial sizing. So, for example, this is the extruded view of the ETABS. So, screenshot lang ninyo, then paste ninyo here in your PDF. Or you can use the document, the Microsoft document directly. So, it's up to you guys. So, depende din sa pag-prepare ninyo ng report. Then, for every color, so we have a corresponding sizing here. And, of course, for every label, this is the NGL, meaning this is the grid beam. And this is the first floor. Or sa atin kasi, sa Middle East kasi first floor, second floor yan. Second floor level. Pag sabihin first floor naman sa Middle East, that is the second floor level. So this is the slab, as you can see. So medyo mahaba to kasi as you can see. Ito, thicken slab lang yan. This is more thicker compared to the yellow color. Kasi nga, kailan namin mag-reduce dyan. Kasi kapag mag-provide tayo ng beam dyan, dito, so medyo congested na. And the client wanted to make it thinner. So in that particular side. So kapag mag-produce tayo ng beam dyan, medyo deeper ang requirement dyan. Kasi mahaba. So that's why we just required or prepare the thicker slabs introducing instead of introducing the beams and the columns. Initially, there's a column there. Kasi may stair to dito eh. So, we just propose a thicker slab here. And this is the roof level. Para sa roof natin. Naka-roofing lang to eh, as you can see. And ito lang nag-iba kasi medyo mahaba to eh. 2.4 plus 4.199. So approximately that is 6.5 meters. And this is the roof framing schedule. Ano lang yan extruded lang yan, then copy paste. Screenshot, then paste here. Then as you can see, depending on the color, we have a different section based on the section and the ETABS. Okay. And this is the section. And this is the footing layout and schedule. Actually, this is the initial sizing based on the 125 kPa cell bearing capacity. assumption. But as for the client, we need to consider the 100 kPa because that's the previous value that they have considered by the nearby building. And we have here the corresponding sizing based on the color. And this is the pressure diagram, control diagram. And as you can see, this 125 kPa cell bearing capacity. Then when using 100 kPa is BC 100 kPa, so nag-change siya, medyo nag-increase siya ng konti. Pero okay naman siya. Kung compare naman sa ito yung gagamitin natin ito, itong size na 'to, pero 125 kPa kasi. So, to more conservative, ito yung gamitin ng 100 kPa. Then, this is the corresponding rebar na kailangan natin. So, yung design na 'to is directly from the ETABS or from the safe. Pwede ka dun mag-design. If you are using ETABS Ultimate, you can design and analyze footing there and model directly. Pero kung plus siya, so you can export it directly to the safe and you can analyze and design the footing or foundation that you have. Okay? Ang kailangan naman sa sa design ng foundation is you need to check the allowable settlement, the soil pressure, and the design. That's all. Based on the geotechnical report. Okay? And after this, kailangan of course natin ng ng design. For example, sa beam, I have here the design of the beam. So this for the grid beam. So you can see, mayroon 'di ba? 6 sa taas, 5 sa baba. Because this is as per the maximum forces and the level of the grid line. I mean, and the grid beam. So I just consider first the maximum forces, then I put here and the struct X Pro. Then initially we will consider this throughout the grid beams. I mean all the beams and the level of NGL. Anyway, we can design this one if it's already finalized, or you can finalize it by designing its member, then you can reduce the reinforcement. Okay. Next. So actually this presentation is okay. This is the updated version of the Struct X Pro. And you can directly connect the ETABS and also the STAAD, and you can export the forces from the frame CE to the Struct X Pro. This for the beams. See, and also there's a calculation for the torsion here. This is good. This is a detailed calculation. And next, grading also, but considering the this is the calculation by crack width and the long-term deflection. Okay, so this is good because I think this is the updated version, because initially I think there's some discrepancy based on the uh, code, but I think this is the updated one. Yes, this is very good. And this is for the grid beam also, and this is for the stair beam, and this is for the first floor beam. So for every section, I just analyze and design only one section. I mean one rebar schedule for each section, considering the maximum forces. So kung mayroon kang tatlong section, then yan, tatlong ano lang siya, design. But if you want to make it detailed and to listen the rebar ratio. Pwede mo yan ano, you can analyze and design each member depending on its corresponding forces. Here, and this for the 250 by 350, and this is for the roof beam. And for the design, this is the design of the 250 by 250, and this is the design of the 300 by 350 column. So this is good presentation report. Makikita mo lahat. Ang ginagawa ko nga lang dito is the manual input of the forces. Kasi I don't know, possibly the version, there's some error in connecting the StructX Pro to the ETABS. Hindi siya na-extract automatically. Then, ang pinaka-final na ano ko is by manual inputting the forces here. Yun. And actually, this design of the column is also I'm using in the Saudi Arabia para sa mga submittals calculations. So they approve this one. Okay, yun lang guys. Then i-compile na lang ninyo. Then you can send it to the municipality as a design report. And of course, don't forget the summary and analysis report. So kailangan yun. You can extract it from the ETABS, then choose the right input and output data from the ETABS, then compile din nyo. Extract it as PDF or I don't know if there's an Excel. Yes, there's an Excel or documents. Then compile na lang ninyo. Yun ang ano. Pwede na yun i-submit ninyo. Commonly sa Saudi, yun naman ginagamit namin eh. Direct na lang from the ETABS. And for the localized design and analysis, yun na. Parang ganito na rin. Para sa ETABS, I mean, para sa beams and the columns, yan, attach na lang, then make a table of contents, then yun lang, tapos. Yun lang guys, thank you for watching and sana hindi kayo magsawa mag-support sa YouTube channel natin. Of course, I have my Facebook page, RH Engineering also, and I have my profile, Ruel Cepeda, and aside from RH Engineering, I have also FB page, Waray nga Engineer. Yun lang guys, thank you and see you in my next tutorial. Bye-bye. God bless you.